The cricket freezes at the edge of the stream. For its entire life, water has been something to avoid. One careless step could mean drowning. Every instinct written into its nervous system tells it to turn around. Instead, it walks forward. Its legs hesitate for only a moment before carrying it straight into the current. Within seconds, the insect disappears beneath the surface. Then something impossible begins to emerge. A long black thread pushes through the cricket's body. It keeps growing and growing. The thread twists into loops, writhing through the water like a living knot. Before it's finished, the parasite is nearly 3 times longer than the animal that carried it. The cricket was never making its own decision. For weeks, it had been carrying an invisible passenger, one that hollowed out its body, left its vital organs working, and waited patiently for the perfect moment to take control. Scientists eventually discovered the parasite wasn't forcing the cricket with muscles or claws. It was rewriting the cricket's own nervous system using the language of its brain. And once researchers uncovered how it worked, they realized this wasn't just one of nature's strangest parasites. It was one of evolution's most sophisticated acts of biological manipulation. Long before the cricket ever reached the stream, the parasite had already won. Its story doesn't begin on land. It begins underwater. Adult horsehair worms gather in ponds, streams, and quiet pools, where they twist around one another in tangled masses that resemble floating knots of black string. After mating, the females release millions of microscopic eggs into the water. Each egg contains only one objective: find a way back onto land. But the worm can't simply crawl there. Instead, evolution found a far stranger solution. The larvae wait until they're swallowed by aquatic insects like mayflies, caddisflies, or mosquitoes. These insects spend the first part of their lives underwater before transforming into flying adults. When they finally leave the water, they unknowingly carry the parasite with them. Many of these insects don't survive long. They die, fall into the grass, or are eaten whole by hungry crickets and katydids. That single meal changes everything. The cricket believes it has found food. In reality, it has just swallowed its own future. Like a stowaway slipping unnoticed aboard a ship, the microscopic parasite disappears into the insect's body cavity before anyone, even the host, knows it's there. And that's when the real invasion begins. The cricket didn't catch a parasite. It swallowed an escape plan. Inside the cricket, the worm begins to grow, not quickly, quietly. It feeds almost exclusively on the insect's fat reserves, leaving the organs that keep its host alive remarkably untouched. The cricket keeps eating, keeps jumping, keeps avoiding predators. From the outside, nothing looks wrong, but inside, nearly every empty space is slowly disappearing. Imagine stuffing a garden hose inside a soda can. Now imagine the hose keeps growing. By adulthood, the horsehair worm can reach nearly 30 centimeters long, sometimes several times longer than the cricket itself. Its body folds over itself again and again, packed into tight coils that fill almost the entire body cavity. The cricket has unknowingly become a living incubator. Its muscles still work, its heart still pumps, its lungs, tiny breathing tubes called tracheae, still deliver oxygen. Everything essential is left operational because the parasite isn't trying to kill its host. Not yet. Evolution rewarded any worm that kept its transportation alive for just a little longer. Destroy the vehicle too early, and the passenger never reaches its destination. The parasite isn't attacking the cricket. It's preserving the machinery it still needs. And once the worm reaches full size, its next problem becomes much more difficult. It's trapped inside a body that cannot survive underwater. Yet that's exactly where the worm has to go. For decades, scientists thought the parasite must somehow be physically forcing the cricket toward water. The truth turned out to be far stranger. Researchers studying infected grasshoppers and crickets discovered that the worms produce proteins astonishingly similar to molecules found inside the insect's own nervous system. Instead of pulling strings, they imitate them. It's a form of molecular mimicry, like forging someone's handwriting so perfectly that even they can't tell the difference. Those molecules appear to interfere with the cricket's normal neurological signaling, disrupting behaviors that would normally keep it far away from water. The result isn't mind control in the science fiction sense. The parasite doesn't pilot the cricket like a remote-controlled robot. Instead, it quietly changes the probabilities. The cricket begins wandering. Its movements become restless, less predictable, almost as if its internal compass has been subtly rotated. Then it finally encounters moisture, a pond, a ditch, a stream. And the moment water touches its legs, the final program begins. The insect steps forward. The parasite has reached the only doorway it has left. The worm never stole the cricket's brain. It simply convinced the brain to make the wrong decision. The moment the cricket enters the water, the parasite stops hiding. Its body begins pushing toward any available opening. The pressure builds until the worm tears free, sliding out in one continuous motion. It looks less like an animal being born and more like a rope escaping a prison. The cricket, now nearly empty inside, may die from drowning or severe damage. In some cases, if it escapes the water quickly enough, it can survive the parasite's exit. But many do not. The worm, however, has completed one of the most extraordinary journeys in the animal kingdom. It immediately begins swimming. Soon it encounters another adult horsehair worm. The two twist around one another into what early observers compared to the legendary Gordian knot. The image is so striking that these animals became known as Gordian worms. Within hours, mating begins. Soon, millions of new eggs drift into the current. The cycle has restarted, not with violence, but with astonishing precision. Every stage depended on another creature. Every stage depended on timing. Every stage depended on evolution rewarding tiny improvements over millions of years. The forest never witnessed a murder. It witnessed an algorithm refining itself. It's tempting to describe the horsehair worm as evil. But evolution doesn't recognize cruelty. It only recognizes what continues. Any worm that accidentally nudged its host a little closer to water left more offspring. Any worm that failed disappeared forever. Generation after generation, natural selection refined the process. Not because anyone designed it, because every successful manipulation echoed into the future. The cricket wasn't chosen. It was simply the latest link in a chain stretching back millions of years. And that's the unsettling part. Nature didn't invent intelligence first. It invented selection. Selection built chemistry. Chemistry built behavior. Behavior became control. What looks like intention is often the accumulated memory of countless generations surviving one tiny advantage at a time. The parasite never needed to understand its host. It only needed to influence one decision. Walk toward water. Somewhere tonight, another cricket will stop at the edge of a pond. Its instincts will tell it to turn around. Its body will obey something else. Moments later, another impossible thread will emerge into the water, beginning a journey that started long before humans existed and will likely continue long after we're gone. The forest isn't silent because nothing is happening. It's silent because millions of invisible battles are unfolding beneath every leaf, every log, and every drop of water. Most will never be seen. Some will never even be understood. The horsehair worm isn't a monster. It's evolution revealing what persistence can build when given enough time. And time has always been on nature's side.